Let's do a couple code walkthroughs to try and make the advantages of async a bit more apparent. In your GitHub directory, you'll see a few examples here associated with our file folder example. I went over one of them already. That was the file folders short. This was our nested callback hell example. Remember, this is the one that created a multiple directory, subdirectory structure underneath where it was run. So if I run node file folders short, all right, all directories made, I look at my directories, I see data there, I do a recursive traversal of that, I see it's created all those subdirectories, and if I run it again, I have error handling built in because I already have those directories. So let me remove that. Then we did functionally equivalent, but we did, notice the callback hell here was the point, but then we did the version with promises, right? And this promise uses the chained then calls. The resolve doesn't return anything, so we use this empty syntax. We create the directories in order, so we're chaining the results again one at a time, if you will. With a catch block at the end. And again, this I can run, and it won't really show anything different because it's functionally doing the same thing. But our point is that we are getting same thing. We're doing it in a much more readable way, in almost a synchronous sounding way. Now, this one isn't using that indented mini callback hell as I refer to it, but I still have these nested callbacks here, right? It still looks a little bit awkward how this is written in those subsequent statements. By contrast, I can write an async version of this. I have written an async version of this. All right, now this one looks a lot like the previous one. It's still returning the same thing, but there's my async keyword. Now, notice one thing I didn't talk about before is the async doesn't have a dot catch like the then chaining does, and that's because we don't have then chaining. So instead of the dot syntax in this case, we are using a traditional try catch block. So this starts to look more familiar, I would think, to you. But here, the awaits are going inside, so I'm making the directories one after another. Notice this one I'm not using a parallel. There's no parallel example here because I have to create these in this order. I have to create this one and then this one and then this one and then this one. I don't want those things to happen in that pseudo parallel non-deterministic way because one depends on the other, so I individually await each one and create that subdirectory structure. And then after the last one, I can go ahead and say what I finally created. So running this one is, again, it's functionally, it's going to appear exactly the same. Is there something tremendously different? In this particular case, the difference between doing a promise that you see at the top here versus an async, really not that big a deal, right? They're both quite readable. They're both quite synchronous looking. And again, one might argue that this might look a little bit more synchronous and feel a little bit more synchronous than this case with the in nested callbacks and the dot catch syntax. But of course, there's also drawbacks, by the way, to the async version, right? The fact that we have to label this as async and we had to create another function. Notice how I had to create another function here so I could label it async and then call the awaits on it and then call make directories here, where here I was just making a direct invocation and processing the promise return from make dir. So again, a little bit of this, a little bit of that. This particular example, syntactically different, maybe a little bit more readable, but not a huge difference. Now, if you do remember, though, we did have a longer example that dealt with our template approach, right? We had this template callbacks approach, and we had the template promise version of this, right? Where we were trying to take the templatize. Let me pause for a second and bring up my browser. Okay, now I'm set up. I didn't want to waste your time while I was fumbling around with things. If you recall in this template example, we had a set of templates in the HTML subdirectory. We used a query string syntax to substitute each one in. The template structure overall was just a simple table with 3 rows and a middle row that had 2 columns associated with it, and we were just plugging in content to each one of these table cells, if you will. We did this example with a promise last time. Right now I'm running the callback versions of things. So when I run it and I give it a query string parameters with things like 1, 2, 3, and 4, it's going to map those to the numbered files in the subdirectory. I love how Firefox does that by default. And it'll come back with that filled out with its stuff, except for when I'm not running it. So let me run the template callbacks version first and try this again, and there we go. And likewise, I mean, functionally it's going to be the same, but this version was the version using async, right? So this had our read file nested in that callback hell, and we had all this error handling embedded. We had multiple layers of nested callbacks to deal with things. So finding where you were in a particular spot, on top of the fact that we had to know how many things, what the structure of the template was and how many of them there were, to put all this together. So we did a version of it, right? That did the template with the promises. Okay, so that one had our chained ones again. Now again, we've got this embedded callback thing going on here, but this one, I'm not going to run this one again because we've already run it before and we know that it works, but does functionally the same thing. So definitely more readable and better and so forth, but we still have this nested callback, kind of mini callback hell going on, if you will. So we can do an async version of this and try and clean it up even further. Right? So here's the same code, and here's the async function. Now again, like the previous example with file folders, I had to create another function here so I could label it async, and then I call that from the create server. So there's in addition, this code looks slightly different because I had to refactor a little bit. But notice how short my create server is now because I moved a bunch of it up here in that refactoring so I could label it async, and I could go ahead and do the await on the reading of the template first. Then I can insert the banner. Then I can insert the left nav. Then I can insert the footer. Then I can insert the main, and so forth, and go forward. So this one's been added to your code repo. I can stop this one. I can run that one and go back to my browser. And again, just to show you it's running and doing something different, I'll load in different content. I'll load in a different left nav, and there you go, right? Same thing, still running. Now, we're doing stuff that's functionally equivalent. It looks a little bit different. I mean, the real argument so far here is that this looks a little bit more readable and natural to the synchronous programmer, especially somebody coming from a language like Java, than the one using promises that still has this kind of funky embedded .then syntax with embedded callbacks and error handling inside of my longer create server, right? It's just, the argument is that this is a little bit harder to read and follow still than a version that uses async await. But underneath, the implementation mechanism underneath the hood is still, there's still promises going on here. That's what we await on. Now the next part of this is maybe we can notice that there's some independence here in each one of these, right? Once I read in the template and I look at the structure of the template, I can start to think of, wait a minute, I don't have to substitute in any particular order. I don't have to deal. I mean, these don't overlap. There's no overlapping computation or manipulation. Now, it is one string that I'm outputting, the HTML I send to the browser, but beyond that, these things are mutually exclusive in a sense. So, could I find a way to pseudo parallelize these things, using my promise.all construct? Well, one thing, try to do brute force. All right, this is the template async version 2. One thing was to take that async and try and apply an await promise all on the read file and replace. But when we run this, we're going to see that this isn't going to work. Let me stop this one. Let me go back and run number 2. All right, and if I go back over to my browser and to this tab, and I'll change parameters slightly. I'll change the banner. Right? Well, I wound up getting the template file back, not the rendered part of it, and it came back immediately. So what happened here? why does this happen? What I'm awaiting on, right? So here's, again, let me slow and show you. First thing we do is await and get the template file. So we got the template file and we stored the results of that we bound it to the result variable, and then we go forward and try to do a promise.all where the logic is we're trying to do a read file and replace on each of the independent sections of the template. All right. But the problem is I'm passing state through, right? The result is something that I already returned from a previous, it's the content of whatever was in that file. So I have some notion of state here. And so I'm trying to take the result and have that substituted in the result here. But the result really comes back as a string to each one of these variables and can't be done in parallel. I mean, the state is lost as I go from each one to each one, and I wind up back with the original template. Okay, so instead, slightly modified this version, we have to realize, and this is really kind of a better practice anyway, is I had to refactor out the file part and the replace part, right? And this replace part is just using the string replace versus the read file part, because the read file part is the part that was really asynchronous. Now I can apply the await here. The await here says I'm going to go ahead and read in all 5 files. Here I even rolled a template in here. I'm going to read in the template. I'm going to read in the appropriate banner file, banner 1, 2, 3, or 4, or 1 or 2 I have. The left nav 1 through 4, the footer 1 or 2, the main 1 through 4 that's in that subdirect. I'm going to read all those in. And so what I really wind up with are 5 strings. Each one is bound to each element of this iterable, really this array, which means when I go down here and I want to go ahead and do the replace, well, this replace right now is going to happen in sequence. The replace function is not asynchronous, so I don't have to worry about putting an await here or anything else. So I'm just going to go ahead and slam those 4 pieces of content in their respective places. All right. So a little bit of refactoring into finer grained behaviors is the point, right? I'm making a finer grained behavior with returning a promise around just the read file and not the replace part allows me to partition my work and use a promise.all in the appropriate ways to make this run a little bit more efficiently. And we'll see this version should work. So let's change another parameter here. I'll change the footer this time. And boom, there we have it. Not really scale. I mean, not measuring performance time, but actually that should happen just a little bit faster than the other examples due to the use of the promise.all and that one single await on it, as opposed to, again, promise chaining or awaits on each individual file like the async 1 version. So there's some quick code walkthroughs, and I know these are quick, and I know that I'm flipping between screens quickly. For you to understand what's going on, you really need to open up this code in an editor. You need to do some slight variations of it to see how those variations might impact things. Maybe there's additional improvements and refactorings you want to do. Go ahead and fork and send me improvements. But the point is you've got to take some time and go through this in a little bit of detail to get your mind around what's going on. But in essence, async is really that syntactic sugar. It's still promises going on, but now we're making it look more and more like code we're used to reading, with just that little bit of intrusiveness with these keywords. But all in all, this is much more readable and looks like code I'm used to reading, as opposed to nested callbacks in promises, or nested callbacks in an asynchronous callback chain, mini callback hell, full-blown callback hell. This doesn't look like that, right? And that's what the benefit is.